If you're looking for a job in software engineering, you're probably wondering about the technical interview and what kind of questions you'll be asked. And in this video, I'm going to go through one of the most popular services for preparing for technical interviews. And I'm just going to pick one example for us to look at. So I'm going to switch over here. And I'm on LeetCode currently. If you're not familiar with it, I'm not going to go too in depth, but they basically have large problem sets that you can go through to prepare for technical interviews. And they do a good job of categorizing them so you can focus on different things that might be important for your interview. And generally the way these are set up is you'll have a problem, which is described on the left, and then you'll be able to run your code over here on the right. And you can change languages if you want to, but for the sake of this video, I'm going to use JavaScript. And in these interviews, you kind of have a couple goals. One is that you're trying to get through the problem, but you're also trying to explain how you're thinking about things and like ask relevant questions to make sure you have all the information you need before even jumping into a solution. So I'm going to go through kind of an example of how I would approach that here. So we're looking at majority element, and the notes here are pretty helpful. They're going to be kind of dense with little details and hints that are helpful to write down. So it says, given an array of numbers of size n, return the majority element. And then it says the majority element is the element that appears more than n divided by 2 times. You may assume that the majority element always exists in the array. So this is actually a very specific situation that it's looking for. So we're not just looking for the element that occurs the most number of times. We're actually looking for an element that is going to make up the majority of the list. So it's going to make up half of the list plus 1 at a minimum. And then in addition to that, so we're just going to make a note of that here. So we're looking for, we want the element that makes up half of the list. I'm going to write it as makes up at least half of the list. But it's really going to be n divided by 2 plus 1. And in this sentence here, they're saying you may assume that the majority element always exists in the array. So what that's telling us is if we have a list of just 2 elements that are like 5 and 10, in that situation, there isn't a majority element because there's an even number of elements and they only occur once. So kind of one bit of additional information this gives us is that it's safe to just assume if something has occurred n divided by 2 times that it's the majority, because you're not ever going to be in a situation where 2 things have equal weight in the list or equal number of occurrences. So that's why I said at least half of the list here. And that'll be important in a minute. I'll show you why. And then they give us a few examples, or a couple examples. So here we have a list with 3, 2, and 3, and it's pretty obvious that 3 occurs is the majority element in this list because it occurs twice out of 3. And then here we have 2 occurring 4 times in the list and 1 occurring 3 times. So 2 is going to be our majority element. And then in addition to that, there's some constraints down here. So it's just reminding us that n is going to be the length of the array of numbers, and that the length is going to be between 1 and 5,000. And then any number in that list could be between negative 2 to the 31st up through 2 to the 31st minus 1. So it's just letting us know there's a really broad range of values in this list. And then there's kind of a challenge down here that says, could you solve the problem in linear time and in order 1 space? And I'll try to talk about some trade-offs with that constraint. So I'm going to make a couple more notes up here about things that are important. So we want to try and do linear time I'll kind of make these challenges. So I'll call these like challenge 1 and then attempt order 1 space or constant space. So that'll be our second challenge. So if we're going to do this in linear time, if we're going to try to do this in linear time, what that means is we kind of need to either only run through the list once and kind of compare. That would mean kind of comparing as you go, or once at the end. And then we also don't just want to like copy. We want to try to avoid making like large copies. Avoid making copies of data, especially approaching size n. And there's different solutions to this. They're going to have different trade-offs about the space or the time it takes to go through the list. So if you were really clever, one thing you might notice right off the bat is that something you could do is you could take this list of numbers, and because the majority element is going to appear in at least half of the list, or half of the list plus 1, you could just sort the array, and then you would end up with, in this case, you'd end up with 2, 3, 3, and then you could look at the middle index. So something you could do for just a quick answer to this is you could say you want to get the index for the middle of the list, and you could do this with or without. You could do math floor or math ceiling, but I'm just going to do floor in this case, and that's because really because of the constraints they gave us, we could just look at the lower of the middle indices, and then once that's sorted, once we have once we know what that index is, we could just basically sort the list and then just pull up the index for it. So we could return nums dot sort of the index, and if we do that, this will actually work. So let's just run it. So you can see it's going to work, and this just relies on some of the nuances that the clues that it gave us in the problem. So because we know that for something to be a majority element, it needs to appear in at least half of the list, we can just sort it, and then we can look at the middle index, and it should appear there. So this would be like probably the shortest way, or one of the shortest ways to write this solution. The problem with this is with the sort. So sort is going to be somewhere between n squared, order n squared, and order of nlogn. And that's because if you're going to sort a long list, you're going to need to compare, at worst case, you're going to need to compare an element to all the other elements to figure out where it's going to fit in, and do that for each element, which is how you get n squared. So for n things in the list, you're comparing to n things in the list. And then a slightly better case would be like nlogn. So that means you're comparing an element in the list to kind of the remaining unsorted, or some subset of the total size of the list. So in some cases, you don't necessarily have to compare to everything else in the list, but kind of fewer items as you go. And one way to think about that is like if some part of your list is sorted and you find the next element, you only have to look through, the sorted part to figure out where it goes, and then kind of do that, repeat that process. So the reason I'm bringing all this up is because this is not going to give you linear time, but it is going to give you, it can potentially give you constant space, because you can sort a list just by kind of like swapping indices in it. So I'm going to show a solution that gives you linear time but doesn't give you order one or big O one space. But I think it's a nice solution. So the way I'm going to do it is actually just walk the list. And a naive way you could do this is for each element that you run into in the list, you could just make another array, and then in that array you could use the number as the index. So like in the example here where we have 3, 2, 3, you could try to like reference the third index and then store a count there. But the problem with that is because the values are really broad, you're going to be going from anywhere between -2 to the 31 to +2 to the 31. That array would need to cover that full range, so it would just be like kind of ridiculously large. So you don't want to do that. But another approach you can take is you can just make a hash, which is in JavaScript just going to be object literal. And what we could do is basically each time we hit a value, we could do something like this. So say 3 is the first value we hit. We could say for the key 3, we want to store the value 1 because we've hit our first occurrence. Or as we're walking the list, it's probably actually going to look more like that because we want to take however many occurrences we found so far and add 1 to it, increment it. And then another little detail is if it's not initialized yet, if we haven't run into it, we'll get undefined when we look it up. So if it's undefined, we want to initialize it to 0. So this or 0 is just a little shorthand for being able to do that. And then add 1 to it. So this is kind of the rough approach we're going to take starting out. So we're going to walk the entire list. And there's lots of options for iterating over arrays or lists. But for these kinds of problems, I usually like to start with for each. So we want to hold on to, we're going to call this our count. So we'll say let count equal occurrences, and that'll be for a given number. And we're just going to hold on to this for a second. So we'll get our count first. And then basically what we'll do, sorry, I'm pulling some code over to you just for efficiency that I've written previously. So we're gonna want to set our occurrences for the number to be that count. And then if we do this, when we do this, basically what's going to happen is we're going to build up this hash here where the keys are the unique numbers that we run into, and then the values at those keys are going to be the number of times we've run into the number. And some advantages of doing this are we're only going to get entries for the unique numbers that we run into. So, if we only have 2 or 3 numbers on the list, we're only going to have two or three keys. If we, worst case, if we got a list of 5,000 unique numbers, we would end up with 5,000 keys and values. But that would be as big as this ever got. And if this didn't have a bound on it here, this could be a really bad solution. So knowing that this is going to be a relatively small number makes me feel comfortable doing this. And then when we're done doing this for each loop here, we're not actually going to have the thing that we need to return. So we need to return the number that is the majority element, and we don't have that. We just have this hash that stored all the numbers that we ran in, the unique numbers that we hit, and how many times they occurred. And you could do something once you have that where you go through and you look at all the keys and their values and compare them and find the max. But that would be causing you to go through the data more than just once. It wouldn't be quite like twice, but it would be It could be up to 2n, but there's a better way to do it, basically. So as we're going through this list, we can just start tracking. Again, I'm just going to copy this over because I have it available. We're going to bring over the two things we really care about. So we need to ultimately return the max key, or the this is basically the majority element. So what we can do is, as we go through this list, we can say, if we've run into this, hold on, I'm just going to bring this over. If the count that we have for this given number is greater than our max count, which is going to start at 0, then hold on to the number as max key and hold on to the count as max count. And then what that's going to do is, like, say we're walking this array and we hit 3, we're going to have a count of 1 that's going to be greater than our initial max count of 0. So we'll hold on to 3 as the max key, and we'll hold on to the max count that we've run into. And then when we go through and we process 2, it's going to end up with a count of 1. And in that case, 1's not going to be greater than our max count. So we'll just skip over this and just keep going through the list. And then we will end up, when we hit 3, also having... or we will end up having the new count greater than the max count. So it'll go from, there'll be a count of 2 and a max count will be 1. So then I'll update that. And then at the end, we should just be able to return max key. And so if we run that, this should work. So we got a functioning solution here. It's saying that for this input, here was our output, here's what is expected. But we can, and this is an okay solution. I don't think there's anything wrong with this. But if we go back and we look at some of the things that we know, we can actually make this better. So because we know that the majority element is going to occur at least a number of times equal to half the size of the list, when we get to that point, we can just stop. We don't have to keep going. So what we could do is we could say, if our max count is equal to our target count, and we'll set that, then we just want to return. So we can stop processing the list. And we want to set up a target count. And that's just going to be half of the list size. So if you think about it, like, best case, we have a list that's like 3, 3, 2, and as soon as we hit 2 times, we know that we're good, basically. Like, we know we've got we know we're not going to have an element that has more occurrences than that. So we'll just run this. Yeah, I guess actually it's probably more correct to do math.ceiling. I feel better about that. Let's do that. Sorry, I gotta look up. I can't remember in JavaScript what the math.ceiling is. Let me look that up real quick. Oh, it's math.ceiling. Okay. That makes sense. Oh, actually, I just misspelled it. Sorry. Math.ceil. Okay. Cool. So yeah, with this little optimization, if we, as soon as we hit a number of occurrences that's half of the list size, we know we can just stop processing the list. And what's cool about that is it's actually doing a little bit better than having to process every element in the list. And then again, the trade-off for the solution is that we aren't sticking to this constraint of constant space, because we are creating some additional data as we go. But I feel pretty good about that, because worst case, it's going to be the size of the list, and that's assuming that every element in the list is unique. And in worst case, that's going to be like 5,000 entries, which I'm okay with. So yeah, these are just some of the things to take into account when you're working on a problem like this. And if you can talk about the trade-offs that you're making as you go through an interview exercise like this, it's going to be really helpful, because ultimately, you're working with a team, and you want to be able to make sure you understand the problem that you're solving. You want to ask questions if you don't understand it to get clarification. You want to be able to explain what you're trying to do before you do it, because that's a pretty efficient way to do things. Like, so even if you're a fantastic programmer, and you're presented with a problem and you can think of a solution for it, it may be that for some reason your team would prefer to do like a slightly different approach or solution, or follow an existing pattern. And if you can't explain up front like how you're going to approach something in general, that could be a problem for you. So the more you can just explain like what you're doing, what the problem is you're trying to solve, and like how in general you would approach it, the better off you're going to be. And then ultimately you're going to be probably working with the people who are interviewing you. That'll depend a little bit on probably like size of the company, and some other factors, but there's a good chance that the same people interviewing you are who you're going to be working with. So, if you can just be clear as you're going through things and have a little rapport as you do it, you'll probably do a little bit better in the interviewing process. But that's kind of my take on one of these exercises. If you have any questions or comments, leave those down below. If you like the video, hit like. It just really helps with the algorithm, helps the channel get found. And thanks for watching, and have a great day.